Hello and welcome to this little walkthrough for the IBM Cloud SQL Query service. That is a service in the IBM Cloud for you to run SQL on a broad range of data sets in cloud object storage. And I'm going to start to give you a visual impression first to see how the service looks like and feels like when you start using it through the IBM Cloud Console. I'm now in the catalog view of the IBM Cloud Console, and you will find the SQL Query service here in the Analytics section. Besides a couple of others, you will now see SQL Query, and you can just provision it from here. You can select one of the plans. At the time of the recording, we only have the beta plan, but when you watch this, you maybe already see our full plan. There's a paid plan and there's a light plan that you can provision, but it basically looks and feels pretty much the same. It's just the amount of data that you can scan and the amount of queries that you can run concurrently in the service instances then different in a paid plan and in a light plan. So I'm clicking here create, and after a few seconds I basically get presented already with the console page for the SQL query. So this is the whole provisioning time that it took for you to provision an instance of SQL query. And then you can immediately start using it. I mean, there's a lot of things you can already start learning here, but for the sake of the demo, I'm just going to the UI. And this is an interactive SQL UI that allows you to start authoring and experimenting with SQLs and basically developing your SQLs that you want to use running against your data on object storage. For this demo here, I'm not going through the tour. You can do that when you do it yourself. I'm just taking one of the samples. As you can see, there's a series of example queries that you can just choose from, and of different levels of complexity and also different sized here in this set of examples. So you just get an impression join here. So you can also see that you can of course correlate different data sets together in a single SQL. And I'm clicking run and let this go. So this is now my first SQL that I'm running in this new instance. And please notice that you didn't provision anything. You didn't even provision the data that we are using here, because we do have sample data sets provisioned for you out of the box so for you to get going. After basically 3 different tables, and those tables are basically data on cloud object storage indicated here with this URL format in a certain region of the object storage or cross region, a bucket, and the object name. You see the results here. You can also verify the SQL that you actually have run, because you will you'll have a longer list here eventually when you run multiple examples. So you can always just check back what SQL was actually run for a certain result that you can also look at in this history. What you can also do from here, you can now also continue to work on cloud object storage, because one of the things that the service does is it always writes the result also back to cloud object storage. So this is what you see here in this link. Basically, when I click that, I'm launching over to the cloud object storage console in the IBM Cloud, where you can look at the data that has been produced by this SQL, and maybe you want to go from there and download it, or just delete it if you want to clean up. If it was just for experiments, you can do that here. So this is now the standard cloud object storage UI. I'm now going to walk you through a little bit of the value. We have started by giving you an impression how it looks like. So I hope you could see that it's completely self-service. So that's the whole point. It's self-service SQL. There's no burden of entry. You can just immediately get started. And in less than a minute, as you have seen, you run your first query successfully and can play with the data. And the purpose of the SQL UI that we have seen is basically an IDE, integrated development environment, for SQL statements. for you to author, test, and also to collaborate. Multiple users can collaborate in an instance on your SQLs. The data itself is the data as it is stored in Cloud Object Storage. So there's no database load of whatsoever type. You can just query it, and we have a growing range of data formats that we support: Parquet, CSV, ORC, Avro, JSON, and so on. The thing is, even though there's no burden of entry for you, this thing scales out because we are running it under the hood in a scale-out engine. In fact, we're using Apache Spark at this point to do that, to run really on terabytes of data. And what you're going to be charged for is really only that query. So it's a pay-per-query service, but it supports the full range of SQL, the full ANSI SQL, including analytic stuff, OLAP functions, and also special libraries, like for instance doing location data analytics with spatial SQL. What the service also provides you is a means of operationalizing your SQLs, because everything you can do, you have seen, is available through an API. So there's a basic REST API where you can do everything, but there's also SDKs for different languages that you can use, and there's also an integration into Cloud Function. So we have seen we of running SQL. So why is that so important? Basically, serverless is the ultimate capability of cloud services. It means basically that your cloud infrastructure that is running your cloud services is available to you in a sharing economy, basically an extreme sharing economy. You only basically start paying and consuming resources when you submit something, when you upload data, when you do something. There's no standing cost for you. So you can, as a user, as a developer, you can completely focus on your business goals. You do not have to be worried about infrastructure, standing costs, planning ahead. You can just go and do the things self-service. So it's really the best thing that you can get with a cloud experience. Now, and we do have an IBM Cloud already serverless storage. That's the Cloud Object Storage, which means basically it's pay-as-you-go. You just dump your data, you dump there, you pay more, and if you delete data, you pay less. You do not have to plan for volume size or whatsoever. You can start with kilobytes and grow to terabytes or even petabytes in a single bucket. And along with that, we do have serverless runtimes where you can run your application logic, and this is the IBM Cloud Functions. So you already do have a basic stack of storing data and running logic on this data in a serverless fashion. What now comes on top of this with the thing that we are looking at here is serverless SQL, which basically provides you a serverless analytic capability, scale out analytics on your data that you can use from your applications. So with that, basically you have a really competitive and compelling solution stack for serverless solutions in the IBM Cloud. There's actually a market trend for serverless SQL, and you probably have heard about Athena, which is an offering of Amazon AWS, which does SQL on S3 data on their object storage. It's a bit differently in terms of how you interact with it. It's, for instance, JDBC instead of REST API. But it integrates with a lot of services of the platform, and it charges you $5 per terabyte that is scanned. So it depends on the size of the query. And in fact, that's exactly the same pricing model that we are going for. Google BigQuery, also serverless SQL, a little bit different because it requires you to load data into BigQuery first, but same thing here in terms of the pay-go experience, $5 per terabyte scanned for a BigQuery SQL that you run. And also integrates with a lot of services in their cloud. So in that sense, we are fitting into a market that we do not need to define. That market already exists, and we basically, as the IBM Cloud, basically are responding to that need, to that market, to that opportunity now. The overall consumption model of SQL Query in our cloud looks like this. So you have SQL Query, the service that we have provisioned, and you have seen already the web console that we started to play, to author, to experiment with SQLs. Once you want to basically go further and deploy and operationalize your SQLs, you have multiple options. You can, for instance, embed them into Watson Studio to make use of it for data transformation or in data science workflows, because you can use it out of notebooks. And we have starter notebooks that show you how to do that. You can deploy it as a cloud function, basically, to really participate exactly in the serverless solution stack that we've already talked about. So there's a generic SQL function, SQL cloud function that you can just take and just put as a parameter a SQL query in, and then it behaves like any other cloud function, just that the code in this case is a SQL that you ask it to run. And finally, you can of course use it from any of your applications, with one of the SDKs that we support and that we are going to expand the set of SDKs that we're going to support. The overall architecture is maybe also interesting revealing to you to see where it fits in your solutions. So the point is we have this cloud object storage, that's the data that we're working on, but how does the data get there? So there are two major areas where data comes from. One can be from one of your databases or other data persistencies. It doesn't have to be like, for instance, Elastic or things like that. Your document store like Mongo or Cloud, or really databases. That can be a relational database even that, it does support SQL, but it's also expensive if it grows to terabytes of data. So you may want to archive off the data when it expires after a certain age. But you still need maybe access to this data and need to be able to query it. That's exactly one reason when Cloud Object Storage with SQL Query is a perfect fit. Another general way of getting data is of course acquiring the data in the first place in Cloud Object Storage through one of the data and messaging pipeline technologies that we have in our streaming portfolio. The Message Hub, the IBM Streams, or the Watson IoT platform, they all can land and have connectors to land data on Cloud Object Storage. So once data is there in Cloud Object Storage, and of course you can also upload data that you have on-premise, right? There are various ways, high-speed ways to upload data to Cloud Object Storage. Once you have it there, you can now immediately start querying it just through your application, submitting a SQL that in the SQL query service uses Spark internally to scale out and run your SQL to read up to terabytes of data from Cloud Object Storage, process it, and writes it back to Cloud Object Storage. So that's the whole flow that you should basically be aware of. Now let's go back for the end of the demo to the demo actually. And so we have seen how we can experiment and work with one of our sample queries, and multiple more that you can do. But let's start using some own data here. Here, what I have here is one of the typical scenarios that we see very often SQL query being looked at, and this is analyzing log message data. So message data in general could be IoT message data, log message data that just accumulates and needs a lot of space as you keep it over time, and object storage is just a perfect space for that. So in this case, we have put cloud and access logs from our own cloud and service, IBM Cloud and Service, into Cloud Object Storage. And it's multiple terabytes of data in this bucket here. And I have here prepared data for a certain month, for February, where we collected it this year in February. And it's all in this folder structure, February. So it starts all with object name February. And that's about a terabyte of data now. So it's a couple of hundred or thousands objects here, like multiple thousands of objects that you can see here, all adhering to this format with you can see that the individual dates and some other properties are called out here. And how can I query this data now? So it's really complex, big data. It's not just a single object. In the object storage UI, you can I've specified this filter, and I can say, give me a SQL URL for this filtered set of objects. So I can click here, I copy it to my clipboard, and I'm going back to one of my SQL UIs here, and I can, for instance, start typing up my select, right? So it's maybe I want to start with simple things like this, And in this case, we have stored it as Parquet. So we have to also tell our engine here, the service, oh, please treat it as Parquet and not as another format. And then I can just hit run. So and this will now scan this terabyte of data. Okay, little typo. This will just scan this terabyte of data that was accumulated over the month of February, all log message data, and runs for I think half a minute or something. I've also previously executed a different SQL here that you can see. Let's look at this one. So let's we can also always copy it up to the editor. So if you want to run it again, where I really have done some more sophisticated analysis here. In this case, I was checking all of my Cloud and access logs in February. How many times I did get an HTTP 429, which is basically a plan limit it was hit, right? So the users were trying to access their cloud database more frequently than they had basically were entitled for. So that could be now an upsell opportunity that we can use in order to approach this customer and say, oh, well, you run against this limit. Do you want to upgrade your plan? So that was this thing here, and if you look at the results, you see, oh yeah, all of these account names and how many times they hit this rate limit. And now I can also go back to our little experiment or count star here, and we can see we scanned about 4.6 billion records, but this was just for the count. And it took about a minute, right? And this slightly more complex one here took roughly 2 minutes, right? And depending on the complexity, it might take longer, but it is still, given that it's basically a terabyte of data and it's completely pay-as-you-go and completely serverless ad hoc, it's still really interesting performance that you can get out of this at such an approachable service. So I hope this gives you a good impression of what you can do with the service, and I hope you find good use cases and make some good business for us here. Thank you very much.